Student, you are going to learn capacitance in series. In the previous video, you know what is capacitance and what is capacitor. Capacitor is a charge storing device and capacitance is the capacity to store charge. Now, you are going to understand capacitance in series. For understanding this, we required number of capacitors. Let number of capacitors are 1, 2 and 3 capacitors. The 3 capacitors are connected across a potential V. V is the potential applied across the capacitor. This is the charge Q. Let the capacitance is C1, C2, C3. This is V1, V2 and V3 are the potential subdivided to this capacitance. Let us draw the equivalent circuit. The equivalent circuit, we need one capacitor. This is series, so we write as CS. This is the potential applied. V is the potential applied. Q is the charge. As here you are saying that charge Q is same for C1, C2 and C3. So in series, charge will be remain same for all the capacitance. But potential V is divided into V1, V2, V3. So we will write V equals to V1 plus V2 plus V3. You already know that Q equal to CV. This means that V equals to Q upon C. Use this application at this equation. So you have at the place of V, we use the equivalent circuit. So we will write here Q upon CS. And here we write Q upon C1, Q upon C2, Q upon C3. Q will be cancelled out on the numerator side. So we have QS equals CS equals to C1 plus C2 plus 1 by C3. Thus, from here you see that CS is less than C1, CS is less than C2 and CS is less than C3. That is, when the capacitance are connected in series, then equivalent capacitance in series CS will be less than the individual capacitance used in the circuit. Let us understand it with some another example. For n number of capacitors in series, for n number of capacitor in series, you have 1 by CS equals to 1 by C1 plus 1 by C2, 1 by C3 dot dot 1 by Cn up to n terms. Let us have a numerical. Numerical number first. Suppose I am giving you a n number of capacitors, each of capacitance C. They are connected in series, then what will be the equivalent capacitance? So 1 by CS is equals to 1 by C, 1 by C dot dot 1 to n times. This means that 1 by CS equals to n upon C. So CS equals to C upon n. This is for n number of capacitor in series. In this numerical, here if n is equals to 100 and C equals to 10 microfarad, then what is the value of CS? So CS is equal to C by n. Put the value of C 10 microfarad upon 100. So this is equals to 0.1 microfarad. This is the capacitance in series capacitance. Let us see another numerical. In this numerical number second. In this numerical, I am taking 3 capacitance of capacitance 1 microfarad, 2 microfarad, 3 microfarad. This means that we have 1 microfarad, 2 microfarad and 3 microfarad. 3 capacitance across a potential source. The potential is let this is 220 volt applied. This is C1 equals to 1 microfarad, C2 equals to 2 microfarad, C3 equals to 3 microfarad. Here charge Q, you don't know what is the value of charge Q, and you also don't know what is V1 here, V2 here, and V3 here. This V1, V2 and V3 you have to determine what is V1, V2 and V3 in the circuit, and you have to find what is Q. You also have to find what is C equivalent in this circuit. This numerical asks these parameters to be found out by you. So for this, we have the first equation 1 by C equivalent equals to 1 by C1, 1 by C2, 1 by C3. So 1 by 1 plus 1 by 2 plus 1 by 3. The LCM is 6, so we have 6 here, we have 3 here, we have 2 here, it is 11 upon 6. 1 by C equivalent. So this means that C equivalent equal to 6 by 11 microfarad. Thus we get what is C equivalent. We get what is C equivalent. Now next we have to find the charge Q. The charge Q is equals to C equivalent into V. What is C equivalent? It is 6 by 11 microfarad, and what is V? It is 220 volt. Divide it. It is 20. So you have 120 microcoulomb. This is the charge 120 microcoulomb. Thus you get charge Q equals to 120 microcoulomb. Let us find V1, V2 and V3. In series circuit, charges are same. This means that Q equals to Q1, which is equals to Q2, which is equals to Q3. Charge Q will same for 3 capacitance. So Q1 is equals to C1 V1, this is equals to C2 V2, this is equals to C3 V3 charge. Equating first two term, this first two term, you get V1 equals to Q upon C1. Put the value of Q, that is 120 microcoulomb. Put the value of C1, which is 1 microfarad. So you have 120 volt. Similarly, from these two, first and second, V2 is equals to Q by C2. Put the value of Q, 120 microcoulomb. Put the value of C2, that is 2 microfarad. Divide it, it is 60 volt. Similarly, V3 is equals to Q by C3. Q equals to 120 microcoulomb, and this is 3 microfarad. So this will be 4040 volt. Let us verify this. Verification. Let us see the verification. Verification. We know that V equals to V1 plus V2 plus V3. What is V1? V1 is 120. What is V2? It is 60. And what is V3? 40. Add this. This is equals to 220 volt. Thus we had applied here 220 volt, and this sum up and give you 220 volt. So it is verified. Thus you understand what is a series combination of capacitance. So do like, share and subscribe my channel. Thank you.